To do some more AP review. Right now we're doing 2012 AB free response 2. It is an AB only problem. All right, so I'm going to do a terrible job of recreating this curve, but it is a calculator problem, so you would put in your calculator what this graph looks like. So here we have y equals the natural log of x, and here we have y equals 5 minus x. Close enough. And this area, so this starts at 1 and this intersects at 5. So this area is called R, right? And you're going to put them in your calculator. This was the one I was given first, so I put this as y1 in my calculator, and this is the one I was given second, so I put that as y2, because that's the easy way for my brain to handle things. So let R be the region in the first quadrant bounded by the x-axis and these two graphs, as shown in the figure. Part A asked me to find the area of R. So the trick with finding R is that these are actually two separate areas. It's the area under the natural log of x curve up until whatever this mystery point is, right? And then it's the area under the 5 minus x curve in this window, right? Now, since it's a calculator section, there's really no incentive to find any of these quantities by hand. But the important piece of information here is that I really need this point of intersection. I need to know this point that I'm just going to go ahead and call A. I need to know where these graphs intersect. So the first thing I'm going to do when I put these in my calculator as y1 and y2 is I'm going to hit second calc and pick intersect, right? So I'm going to scroll up to where they intersect, right? And I get as close as I can, and then I hit enter for the first curve, enter for the second curve, and enter for the guess, and I'm going to get a value. Now that x value that you see, which is a 3.6934414, etc., is currently stored in my calculator as x. So if I quit out of this and hit the x button and hit enter, you'll see that number. I'm going to go ahead and hit that and store it as alpha A. The reason I want to store it as something that's not x is when I do another second calc intersect or anything else, x will be re-saved as something else. Whereas this A that I have now saved as A will stay as A until I reassign it or until a program that I have written which uses A as a letter reassigns it. So I'm safe. This is now A. So what I know is that this bound A, right, is, so I'm going to go ahead and write that this A that I'm calling A is 3.693441359. Right? And I just need to write it once. And then because I wrote it out in its entirety once, I can now use that as A. So in part A, the area I'm looking for is going to be this area, right? Area R is going to be the integral from 1 to A of the natural log of x with respect to x, plus the integral from A to 5 of this 5 minus x dx. And even though this is a pretty easy integral, there's no reason to do it. You have a calculator for a reason. So this is what the AP needs to see you write, and then they're just going to care that you skip down to what the approximate answer is, which is going to be 2.986 or 5, depending on if you round or truncate. Like they need this setup and they need this. Now what I'm going to walk you through though is how you type it in your calculator. So I'm going to type in function integrate, right, which is math 9, of what I called y1 with respect to x from 1 to A because I've conveniently stored that as A, plus function integrate, which is again math 9, of what I called y2 with respect to x from A to 5, right? And that's going to give me those values. So again, I'm going to press math 9, right? Vars over to y vars, pick function, pick y1, comma, with respect to x from 1 to alpha A, because I already saved my A, plus math 9, go over to vars, right? Y vars function y2, comma, with respect to x, comma, alpha A to 5, right? And I'm going to double check that where I can see it, because when I hold it up for you, it's hard to see. Looks good to me. I hit enter, and I should get the same answer the AP has, which is the 2.985 or 6, depending if you round or truncate. Again, the AP wants to see this, and they want to see this. They do not need to see, nor should you write your calculator notation. I only write the old school calculator notation, so you know it. Cool. Now, there's another way to do this that the AP also suggests if you didn't want to find this point as alpha A. The other way the AP suggested doing it, just so you know, is you could have solved both these curves for x instead and done right curve minus left curve. So the other way to do this, and the other way that the AP wrote this out, and either one is totally fine, is if you had bothered to find the y-coordinate of this, let's just call that y-coordinate b, and I could go back. I don't even have to go back because I haven't reused y since I second calc intersected. So if I were to type in alpha y, it'll give me the y-coordinate of that point of intersection, and it turns out that it's a this b would be a approximately a 1.306558641, and that's fine. And I could store that as b in my calculator so that it doesn't get overwritten, right? The other way to do this is to solve both of these for y. So if you solve for y, you'd get x equals, or I'm sorry, solve for x, you'd get x equals 5 minus y, and you'd get x equals e to the y. And if you chose to do that, you could do this curve minus this curve for literally the whole area and integrate from 0 to b. So the other way to do this is to integrate from 0 to b and do this curve, which is the rightmost curve, so 5 minus y, minus the left curve, which was e to the y with respect to y. And that's absolutely fine. If you put this in your calculator, though, it makes more sense to use this as x's anyway. So if you chose to put this in your calculator, you would probably do function integrate, and you could do with respect to y, it's just weird. You'd do 5 minus x minus e to the x with respect to x from 0 to the thing you stored as b, and you'd get the same answer. You could do it in your calculator with using the letter y, but I think it's a safer bet to go ahead and just use x because that's what we're comfortable with. The AP showed either version of part A. It doesn't matter to me which one you do. I would default to this one. Either way, you had to find that point of intersection, which is a really important calculator skill. All right, second part. The region R is the base of a solid. Oh, we're going to have to find volume of something. It's going to be the base of a solid with cross-sections that stand up in a certain shape. So the region R is the base of a solid with cross-sections perpendicular to the x-axis that are squares, right? But do not evaluate an expression involving one or more integrals to find the volume of the solid. So in this situation, because my solid has cross-sections perpendicular to the x-axis, it's going to turn out that it really is important that I know what A is. So my cross-sections go this way, and standing off of this thing, they are a square, right? So in order to find the volume is going to be what happens if I add up all the cross-sections, right? Like all these cross-sectional areas. So the cross-sectional area in this window is going to be top minus bottom. So on the window from 1 to A, the cross-sectional area in terms of x would be top minus bottom, which is natural log of x minus a 0, quantity squared. But on the window from A to 5, right, on the window from A to 5, my cross-sectional area is going to be top minus bottom, which is 5 minus x all minus is 0 squared, so it's a 5 minus x quantity squared, right? So the reason that's relevant is my volume, in general, my volume in terms of this whole shape, right, the volume that I'm going to have, is going to be the integral of the cross-sectional area, oh, not 0, my bad, from 1 to A of this thing, quantity squared, with respect to x, because that's the area thing is being integrated from 1 to A, plus the volume of the second half, which would be, it's not really halves, but the second piece, from A to 5 of this area, which is 5 minus x quantity squared with respect to x, right? So it's both of these things, right? So again, unfortunately, like if you did part A the other way, the way where you solve for y, that's going to actually serve you kind of badly in this problem, like this part B, because you really need to recognize that they're two different shapes and that the cross sections go this way, okay? So again, when you're doing cross-sectional area, think about it like it's plates sitting in a plate rack, right? So there's a square plate here that's really small, and then a slightly bigger square plate, and then a bigger one, and a bigger one, and a bigger one, and a bigger one, and you're adding all the plates. So the area of one plate was natural log of x quantity squared. You're adding all the plates. The trick here is that you have two different plate racks, right? You have the plate rack that uses this chunk, the natural log of x chunk, and you have the plate rack that uses this chunk, which is the 5 minus x. All right, cool. That's part B. Part C. The horizontal line y equals k. Oh, I need another picture. Let me make this slightly nicer. All right, so the horizontal line y equals k divides R into two regions of equal area, right, but do not solve an equation involving one or more integrals that gives the value of this area. Okay, so there are two ways to do this. I actually did it the opposite way from how the AP did it, but it doesn't really matter. So this is y equals natural log of x. This was that y equals 5 minus x, right? And that ends at 5. Okay, so what they're saying is there's some horizontal line. Let me find a different color. So there's some horizontal line y equals k right in here, right? And that horizontal line y equals k cuts this thing into two equal regions, right? So this is y equals 5 minus x. So what they're saying is that this is half of whatever r was, and this is half of whatever r is, right? which is R is the value that you found in part A, right? The 2.986, whatever. So there's a couple ways to do this. This is when it comes back to being easier if you did it the second way that we talked about in part A. Again, either way works. So the way I chose to do it, right? So there's a couple different options, right? One way to do this, right, is to use the other version of these, the ones that are solved for x, right? And if you use the other version of these, the x equals 5 minus y, the advantage to using the other version is you could say if you integrated from 0 to k, right? So you could say that if you integrated from 0 to k in terms of y of this thing minus this thing, so the 5 minus y minus e to the y, you could say that that should, with respect to y, you could say that that should be equal to, and then you could either integrate from k to b, like you could either say that this is equal to the integral from k to b of this thing, which would be true, right? That would be one way to do it, like that's option one. Another way you could write this is you could say that this thing, right, this thing, which is just this area, right, is equal to 1/2 of whatever you got in part A, right, which is this, or this, right, depending on which one you picked. That's another way to write it. But so either of these are sort of the easier options, right? Or you could have said this was equal to 1/2 of R, or you could have said double of this is equal to whatever you got for R, and that's fine. Those are kind of what the AP was thinking, right? That was the AP's goal. If, unfortunately, you made the same bad choice that I made, which is maybe your brain was not able to pick up on the fact that they wanted you to solve these for y, there is another way to do it, and I just want to throw that out there. The other way to do it is to find whatever these coordinates are, right? Find this, like I'm going to call this point C just for argument's sake, and I'm going to call this point D. I could find both of those, because in both cases, if y is k, so the third way to do this, and I'm going to say ahead of time that this is not ideal, but I'm addressing it because sometimes your brain doesn't see the shortcut. Sometimes your brain doesn't see the ideal way to do this. And if your brain did not see the option to solve these two equations for y, it might have made your life a little harder. So one way to do this is to find this point C, right, and say, okay, well, the point C is when k equals natural log of x, so k is natural log of x. So e to the k must be my x. Oh, point C is whatever e to the k is, right? And point D must be when k equals the 5 minus x. So x must be 5 minus k, right? So that must be what point D would be, right? X, so 5 minus k. Okay, so another way to do this, and I know it's totally crazy and absolutely ridiculous, but another way to do this is to break this guy in and say if you integrate from 1 to c, right? So another way to do this is to say 1/2 of whatever r is, which was the 2.896, I think, or 895, right? 1/2 of that thing should be equal to the integral from 1 to what you called c, which is e to the k, of this natural log of x with respect to x, plus, and then for this chunk, right, for this chunk, you're actually just integrating k with respect to x, because it's just y equals k, like you just want this piece, k minus 0, from e to the k up to 5 minus k, right? Plus, you could integrate from d to 5, which would be from 5 minus k up to 5, of this curve, 5 minus x dx. And that's another way to do it. So that's a third option. And there are other options that use this same basic skill set, right? It's not fun, but it's a possibility. The other way you could do it is to set this whole ugly thing here, which is this chunk down here, equal to another way to write this, right? The other way to write it, another thing this would be equal to, is the integral from c, which was e to the k, to the thing I saved as a, right? That was a originally, of natural log of x dx, plus the integral from a to the thing I called d, which would be, in this case, 5 minus k, of 5 minus x dx. And that's another way to write it. So the point I'm making is that sometimes you're not going to think of the way the AP wants you to do a problem, and that's okay. If you see a solutions guide and you're like, hey, I'm really sure my answer's right, but it doesn't line up, just ask. If you're somebody that's in my class, ask me or email me. If you're somebody who's watching this video and isn't in my class, put it in a comment in the videos, and that's fine.